Welcome to our video on section 8.3, confidence intervals for one population mean when sigma is unknown. So we have previously discussed confidence intervals where we knew sigma and we could use a z distribution to find our confidence interval. We have not yet discussed what to do when we don't know sigma. So we have to use a different distribution, and that distribution is called the t distribution. We can take a look at that curve. So let's compare it to our normal curve, our standard normal curve. We can see that the green curve is our standard normal curve. It's centered at 0, and it has a standard deviation of 1. Our t curve is also centered at 0. It's also symmetric. But if you take a look at the tails, you can see some differences. And you can see some differences between the two t curves shown. So the blue curve is a t curve with degrees of freedom equal to 1, and a t curve with degrees of freedom equals to 6 is your orange curve. Notice that with a higher degree of freedom, the t distribution looks closer to the normal distribution. We're going to discuss that a little bit more later. The big picture here is that the t curve and the z curve are pretty similar and have a lot of similar characteristics. But if we don't know the population standard deviation, we have to use the t curve to create our confidence intervals. So we had a z variable, which was our standardized version of our sample mean. Here we have the studentized version because the t distribution is frequently called a student distribution. So the studentized version of the sample mean is just this, using this formula here, t equals x bar minus mu over s divided by the square root of n. Notice that this looks pretty familiar. We replace t with z, or z with t, and now instead of having our population standard deviation in our denominator, we have our sample standard deviation. So remember, you may have to go back and practice calculating a sample standard deviation if you were given raw data. Or if the data was large enough, you might want to use SPSS to calculate that standard deviation. Let's go back. So at the bottom, you see the t distribution has n minus 1 degree of freedom. You're going to need to know how to find the degrees of freedom in order to look up a t value on a table. So these are the properties that we already discussed, right? Except we didn't talk about the total area under a t curve equals 1. That was the same property we had with a z curve. Again, the t curve extends indefinitely in both directions and never touches the horizontal axis. It's symmetric about 0. And as the degrees of freedom become larger, the t curve looks more and more like the standard normal, which is a great property for it to have. So if you look in the appendix of your ebook, you'll find a t table, or you can just look online for one. It's a t distribution table. And across the top, you're going to find t sub alphas. Okay, so those alphas are your critical regions, or your tails of that distribution, just like they were with our z table. The difference is in our z table, we were looking at the interior of our table with that area, and here it's along the outside of our t table. So you can think of the t table and the z table as in some ways being inverted from each other. Okay, so in a t table, you find the t values on the inside and you look for the areas on the outside. The outside, by outside I mean you're looking for the subscript of the t. So if your alpha is 0.05, that means you're going to look for a t sub 0.025 because we have to divide it by 2 for our confidence interval. Along the left-hand column, you see the degrees of freedom, and that is just your sample size minus 1. Our procedure is very similar for the t interval compared to our z interval. So we have a few assumptions, and they're similar to our previous assumptions. We have to assume a simple random sample, a normal population, or a large sample. And by large sample, we mean a sample larger than 30, or equal to or larger than 30. And here, sigma is unknown. And now we just replace in our confidence interval formula our margin of error. Notice that our point estimate is still x bar. And our margin of error looks pretty similar to our z interval procedure, except we have replaced z with t and sigma with s. So when our population standard deviation is unknown, we have to rely on our sample standard deviation as our estimate of that, and we have to change our distribution value that we use. So here we have to use t. Okay, so we're not going to go through an example of this until Monday, but you should be able to use this in your homework and get started on your homework problems. Let's take a look at checking our assumptions. So we assume that we're in a situation where we have a normal distribution or a large sample size, but we still want to check for outliers. So here, this data has been put into some software to provide us with a normal plot, right? Now, this is the losses for a sample of 25 pickpocket offenses. So if we look at this graph, we see that it looks approximately normal and it falls roughly in a straight line, all right? And there's nothing that seems too far away from that straight line. You could argue that this point down here at -2 might be a problem, but it falls pretty much in line with the rest of the data, so you're okay to proceed. What about if we look at data for chicken consumption? We see that there is one point that's an outlier. So as we discussed in the previous section, if you have an outlier, you should really report 2 confidence intervals, one with the outlier and one without. And you should discuss this before moving on. You should not just remove the outlier and move on. You need to either calculate your confidence interval with the outlier or report both. So that's because we never want to assume that an outlier is a mistake or an error. It could be a legitimate value that's part of our data and part of our distribution. So you can't just eliminate them without careful consideration. All right. So from here, you should be able to take a stab at your homework on section 8.3. We will go over homework questions on Monday in class and do an example together. Now, your project video is going to be uploaded tomorrow afternoon, and along with data sets will be uploaded to Blackboard as well. So have a wonderful, wonderful Halloween.